All right, so today we're going to talk about simplifying rational expressions. So we're going to talk a little bit about what rational expressions are and how to simplify them. So when a fraction or when several fractions have common factors, we can cancel those factors out. So when I'm talking about rational expressions, it's really just a fancy word for fractions, although fractions usually only refer to numbers that or fractions that have like a numerator that's a whole number and a denominator that's a whole number, whereas a rational expression may have some variables in there too. We'll talk a little bit about the difference shortly, but just think of fractions as being rational expressions and rational expressions as being fractions. The difference between them is very subtle, so we can kind of just think of them as being the same thing. In any case, let's try this example. So if I was to be asked to simplify 42 divided by 12, well, what I'm going to do is I'm going to factor both the numerator and the denominator, and I know that 42 is equal to, well, it's 6 times 7, which is 2 times 3 times 7. And 12 is, well, that's 4 times 3, or 2 times 2 times 3. So I've completely factored the numerator and the denominator. We call that its prime factorization. And now I can cancel out common factors from the numerator and the denominator. Namely, they both have a 2 as a common factor, and they both have a 3 as a common factor. And what I'm left with is, well, all that's left on the top is a 7, and all that's left on the bottom is a 2. So 42 over 12 is equal to 7 over 2. Now, if I was to be asked to simplify this fraction, well, I would actually consider this to be a rational expression. I would first I would think about the coefficients on the numerator and the denominator and think about any kind of common factors they may have. And then I'm going to look at the denominators, the variables rather. I'm going to look at the variables and see if they have any common factors. So I'm going to write it like this. And I don't always write it like this. I'm only writing it like this just to help our learning, okay? So when we do a few more examples, then we'll kind of cut to the chase and write less. But just so you can really see what's going on behind the scenes, I'm going to really write it out in its entirety. So this is equal to, 14 is 2 times 7, and I'm going to start using the dot notation for multiplication. We've got 2 times 7, and x squared is x times x, so this is x times x. And on the denominator, 21 is 3 times 7, so I've got 3 times 7 times, and just a single x left. And just like before, I'm going to cancel common factors, so obviously the 7 has got to go. And now, the x, remember that the x is a variable, so it actually represents a value. So no matter what value that is, and I'm going to just have to put a little asterisk there because I do have to amend this. But no matter what value x is, these are going to cancel each other out. So let's say x was 4. Well, then we would have 4 in the numerator and 4 in the denominator, and they would cancel out. So what I'm left with is that this is equal to 2x over 3. Or if you wanted to, you could also write it like this, 2/3 times x. Let's talk about this asterisk here. What does that mean? Well, there's one specific value that x cannot be equal to. So note, if x was equal to 0, we have a problem. What's the problem? Well, if x is equal to 0, well then this would be 14x squared over 21x. Well, that's equal to, 14 times 0 squared is 0. 0 divided by 0, that is what we would call an indeterminate form. It means that it actually is equal to something, but we're not sure what it is. It's a little bit different than what you may have already seen as undefined. Undefined and indeterminate are very, very similar ideas, but they are different. In any case, we're going to get something that doesn't really make sense. 0 divided by 0. It's impossible. just ask Siri. Siri has got a great joke that has to do with 0 divided by 0. Anyways, so on the left-hand side, in the yellow, we would have 0 divided by 0. But over here, we would have, well, 2/3 times 0 is just 0. That's not undefined. It's actually equal to 0. So when we start canceling terms, we have to be really careful about not dividing by 0. In particular, especially when we're canceling something in the numerator and the denominator at the same time. That causes a lot of issues. So when we're doing these questions, we have to just always do a little check of which values x cannot be equal to. A lot of the time, it's 0, but we'll soon see that sometimes x is not allowed to be equal to other terms. Now, there's several ways that you can describe the values that x is not allowed to be equal to. The two that we're going to be using, and I'll kind of go back and forth between them, is non-permissible values, or we call them excluded values. No matter how we describe them, we still write them in the same way. Really, all we want to say is that x cannot be equal to 0. Sometimes we actually want to write it as a set. So we would write NPV and make a set, and in this case, it would just have the number 0 in it. Okay, suppose we've been asked to simplify this. Well, right off the hop, I'm hoping that you can see a common factor. The common factor would be x minus 1. So we can cancel that x minus 1 with that x minus 1, and we'll be left with x plus 2. Not so bad. Let's talk about the non-permissible values. So NPV. So because we canceled out an x minus 1, that means that x minus 1 cannot be equal to 0. So when x minus 1 is equal to 0, we have a problem. Now, this is a little bit clunky looking, right? Like x minus 1 equals 0. The form that we want is just to know about x. I don't want to know what x minus 1 can't be equal to. I really want to know what x can't be equal to. So we have to solve for this, and solving this isn't too bad. The idea is that x equals 1. That's our non-permissible value. So our NPV is x cannot be equal to 1. Sometimes we actually write it as x cannot be equal to 1. It's kind of like a double negative, so some people actually want to write the NPVs are x equals 1. As long as you are very clear and explicit about which values x cannot be equal to, that's fine. Don't worry too much about the notation. Just know that you need to understand where x cannot be equal to. Okay, so we're going to do one final example here. So let's say that we've been asked to simplify this. Well, this is a quadratic expression divided by another quadratic expression. So what we're going to have to do is factor both of them to see if they have any common factors. So let's try that out. So that top one, I'm looking for factors of 12 that sum to 7. I hope by now that this is something that comes fairly quickly. So those numbers would be 3 and 4. So I've got x plus 3 times x plus 4 as my numerator. My denominator is, well, I'm looking for factors of 15 that sum to 8. And again, I'm hoping that comes fairly quickly. That'll be 3 and 5. So I've got x plus 3 times x plus 5. Okay, and right off the hop, we can see that x plus 3 is a common factor. So we're left with x plus 4 divided by x plus 5. And our NPVs, well, it's clear that x plus 3 cannot be equal to 0, so x plus 3 cannot be equal to 0, or in other words, x cannot be equal to negative 3. And don't just think about the terms that you've canceled out. In our final and simplified form of the rational expression, right over here, x can still not be equal to negative 5. Because when x is equal to negative 5, then we would have negative 5 plus 4 over negative 5 plus 5, which is equal to negative 1 over 0. That's undefined. So when x is equal to 5, our expression is undefined. X plus 5 cannot be equal to 0, or in other words, x cannot be equal to negative 5. So if we would like, we could write our NPVs as a set. So NPVs, I'll write negative 3 and negative 5. So when x is either one of those values, we have a problem in our expression.